Okay, hello everyone. Uh, for today's class, I would like to continue a little bit, just a few examples, and then we can have some exercise. Okay. Okay. Um, okay. So last time, I showed you that the divergence test. Okay. So basically, for a series, if you have a series that you know that it is convergent, so you know beforehand it is convergent, then for sure the limit is 0. Okay? Be careful. If you are reverse the cause and effect, if you say the limit is 0, it doesn't necessarily the series to be convergent. Okay? So I'm writing here. So if the limit is equal 0, that it doesn't mean that this series is convergent. Okay, this is very important. But if the limit doesn't exist or the limit is not equal to 0, you could say the series will be divergent. Okay, so as easy as that. And just to add some theorem for some property in the series, basically this summation property that you have is also works. Okay? So you could multiply with a scalar and you can factor the scalar, the constant. You can add the summation and you can subtract the summation. Okay, pretty much very basic. So let's go start with this. Okay, just to show you the left part is basically the geometric series. If you could see the forms, which are the form for geometric is AR and -1. This is the pattern for the geometric series. And basically, I think as long as you can define which one is the first term, which one is the ratio, you could go and find how it goes. Okay? And for the ratio that is, so every ratio that is less than 1, for the absolute ratio less than 1, then for sure this will be converge. Okay. And if you get the ratio is greater than 1, this would be diverge. So the idea is just to find which one is the first term, which one is the ratio. If you have this kind of a series like this, have a number, list of number, which means you can just look at the ratio by dividing the second and first term, right? But if you look at this, then it means that you need to do some simple algebraic equations just to separate which one is the first term, the ratio. Okay. Suggestion: if you are having some confusion in this one, you could check each n. For example, n equal 1, n equal 2, n equal 3 to confirm that you are having the geometric series. Okay. I think that will be better because I know for some occasions you will feel maybe confused when you are in a tight situation. So you can check n for each n. Okay. Starting from, let's say, I think all is from 1, except this is from 0. So you can check 1, 2, 3, 4, and so on. Any questions?
Yeah, I was just saying, like, can't you just plug it in?
Yes, that is for confirmation. That will be very useful, especially if you are not really familiar to solve algebraically, and maybe you feel nervous. You can check one by one and checking whether that is a geometric series or not. Okay? Or for this case, it's all geometric. But the problem is whether it's converged or diverged. If diverged, you can stop. If it's converged, you can continue to sum the value. Okay? And remember, to sum up the value, you could use this as A1 minus R. Okay, you directly get the value. Okay? And this one is more combination, but we do only have the geometric harmonic series and I think the divergence test. So I think we could check. Which one do you think is okay? For example, let's start the simplest one. I think number 37 is quite simple. If you want to check this, every time you have a series, you can do the divergence test. Take the limit. Okay, hopefully it's not 0. If it's 0, then we cannot conclude anything. If this is having a value, okay, it's divergent. Stop. You can stop and then diverge. Okay. So let's see this if this is diverge. Okay. So let's just put the limit. And taking into a infinity, and take the equation here, and you will see that this will be a value, right? It will be -1/2, right? And we still have a confusion how I get -1/2. It's from here. So literally we define with n. So this 2/n, 1/n becomes 0, and this will be 1 and -2. So this -1/2. So it's a value, which means that this is diverged. So the very first strategy, if you have like a many combinations of converge or diverge series, the first strategy is using the divergence test. Very easy. Just put limit, and if it's not 0, like if it doesn't exist or it has a value, diverge. Okay, stop, and then you can work with another question, right? So you could say that this diverge by divergent test. Okay. Maybe 39. I think this is very clear, or not? This will be geometry. You can check this 3/n, and you see that this will be, if we try to maybe taking the equations, we could have 3 and this will be 4n, right? And we have 3/4 with power of n and 3. So we have the ratio and we have the a. I think clear, right? Geometry. Let's increase the difficulty a little bit. Let me check which one is. Do we need to calculate? If it is convergent, find its sum. For something like the number 43, sine 100 with power of k. What do you think? I think it could be written as since this is geometric, but you can see that we can write this because geometric is a, r, and -1, right? So we could say that this sine 100 is our a. Let's say this is sine 100, and the rest is just the another sine 100. Okay. So another sine 100, right? And -1. Okay. So basically, this is just going back to the original equation, right? So we could take this as sine 100 minus 1 minus sine 100. You can stop until here, or if you want to compute using calculators, you can just plug in 100 in your calculator. Okay, basically that. Okay, what else? Okay, how about the number 48? Okay, how about number 48? 48, you have supposed to be, remember, we have plus inside the sum, which means we could literally separate this, and maybe we could see this one as one sum, and this second one as the other one. Okay? And we could observe each one of them. And notice that 2 over n, or last week we have the 1 over n, the harmonic series. And that is something that you can try to remember because it will often comes around in the chapter 11. So 1 over n, that is harmonic series, which is divergent as series. So we can write here that since diverge, then the whole sum diverge, okay? No matter what will be inside, whether it is converged, like for example, the 3 over 5 power n, perhaps it will converge. But because of this will be diverged. And so that's also, you can think about that. So this will be divergent. Okay. And whenever you see like this, you can work with something similar with this. So you can separate and maybe think what kind of series is this, what kind of series is this, and maybe taking limit for this one, maybe you can have something. Or maybe here, I believe that is going to be, because it has the power of n, we can write the 1 over e with power of n like that, which means that it is a geometric series, right? 1 over e, and then multiply 1 over e, 1 over e, right? So it could be a geometric, with a is 1 over e, and r is 1 over e. Okay. And what else? And since the r is less than 1, which is the 1 over e, then it will be convergent. Converges. So this one will be converges. So the right here is sigma 1 over e will be converges. And then we could write that this could be written as this one. We can write 1 over e plus sum okay, and then this will be the sum of the 1 over e. We can write maybe here, let me write here 1 over e, right? And then take some time to solve this, simplify. Okay, so we get this will be 1 over e minus 1 for the 1 over e power n, and then plus what will be the sum of this? I think we've done this before, right? This should be equal to 1. You can check later. So this will be the result. Okay, so you can stop until here, or you can continue to combine both of them. Okay. Okay. Actually, there are other questions as well. Okay. Do we have more? Yeah, this is the one with the telescoping sum. Okay, let me add just a small subtopics just to show you that there is one method we call the integral test. Okay, this is, I think, I hope you still have familiarity with the improper integral in Calculus 1. So basically, if you see our series, we have 1 over n squared. And basically, if we take this summation, we add all these numbers, right? And that means if we have let's say a function, like in the improper integral, we compare this with 1 over x, right? So we have, suppose that we have a function 1 over x squared. Okay? We know that if in the integrations, the area under the curve is the integral, right? Right, in the x, let's say x equal 1 until infinity, we can take that as our improper integral, and we can compute that as well, right? But now, the summations, if we want to correctly compute all the each n, when n equal 1, n equal 2, n equal 3, this should be your area, right? Okay, this should be your area. And if you want to approximate, try to approximate and then take some partial sum x. So you are going to add a1 plus a2, and then a1 plus a2 plus a3, and adding all terms. For example, you have n equal 5, 10, 50, 100, 500, 1000, 5000. With some iterations, some numerical tools, you get this number more or less around 1.6 or 1.6 something. Okay. Now, if we get through this, and if we remember when we deal with the improper integral, we are going to integrate this. Basically, we can take this as, so the area under the curve from 1 to infinity, we can take that as integrations from 1 to infinity, 1 over x squared dx. Which we finally see that this will be equal to 1. Okay? And the total area will be the area 1, the 1 over 1 squared, this one,
plus the total for the integration 1. So it will be 2. But that area, this 2, is going to be the whole area,
including this gap. So the exact,
so let me write here. So all, let me write there. Okay, so all partial sums is less than 2. Okay, or we could write here that this will be less than 2. Okay,
this 2 is area under the curve plus this. Okay, this is just to show you that if you could get the integration from a improper integral, we get the value, we can integrate the function in the series. It means that the series itself will converge. Do you get the logic? Because if we integrate, we are going to have the area which is this large. So of course the series, which is this small rectangle, will be also converged. So integral test is not directly giving you some exact number or value. It is just to showing you whether the series will converge or diverge. Okay. So if you have like you can consider from a series, you feel that you can integrate that, and then you can check the improper integral, and then you say, oh, I can integrate this, we get the value, which means that the series itself will converge. Okay. But the problem with this integral test, although it's very simple if you know the integrations and if you know the value, you need to make sure the improper integral, the techniques, the integration techniques itself, the improper integral property, like we did in calculus 1. Okay, so that you need those 2 requirements. But the rest is, the conclusions will be very clear. If we have a value that has, after integration, it means that, okay, then the series is converged. But how much convergent the value is, like what is the exact number? We can only approximate. For example, like this one, we can approximate, okay, 1.6, okay, this is true, less than 2, right? Less than 2, okay, that's correct. We try some high number, 5,000 or maybe more, it's 1.6. Okay, it's true, it's very similar to what we approach. Then I think we could say, okay, this will be converged. So through this proof, using the improper integral, we can say that, okay, the series will converge. Okay.
So we can say that from here, series convergent.
Okay, I found this on the web for his conversion. Check it out.
Why? Okay, so that's the integral test. And another way you could also see something like this.
This is so the difference from the first and the second one. This one is if this is overestimated. If we have this overestimation, we are going to have a little bit different. So this will be the summation will be the total area. So total area.
So here the difference is total area. Is greater than area under the curve, in which we have this one. Okay. But of course, if you remember the improper integral, this will be diverged, right? This will be diverged. If you remember the p test, if this is half, right? It's less than 1, so it should be divergent. But of course, to make it visually attractive, you could see that it is quite large compared to the first one. It's quite small, that it could be converged at some point. But here, it's still, we consider it's still divergent. Like you can see that it isn't easily going to be converged. Okay. So maybe just quick notes here. This is the integral test. So if we can prove convergent, then this series converges. So if we can, ideally, if we can compute the improper integral, and we know the value from the improper integral, whether it's converged or diverged, then the series will also the same. Okay? It will also the same, similar with the series. So maybe let me write here. This is this integral is diverges. Okay. Okay, that's it. Later, if we can have more example, but I would like to start with a little bit story on something that I found. I'm not sure I have talked about this or not, but let me show you. Wait. Do we have? Okay, so this is my prompt in ChatGPT. So I would like to show you some interesting story, and also it's important because it will relate it to your quiz. It's about a polar curve. So I'm trying to. So previously, I'm asking a straightforward questions about calculus, and since I'm using the paid version, it's easily compute using Python, and we can track all the codes and basically if it is direct questions, it will be giving you like an exact solution, right? But I'm trying to do the same thing with polar, okay, the polar curve. So what I want to compute is this, okay? So we have this, the landscape, and the circle. So the question is, I would like to compute the area inside this landscape, but outside the circle. So this gray one, if you can see, this is a little bit grayish. Maybe I should put more colors. Yeah, but let's say this is the area, right? So I would like to know what is that area, and then I'm asking. Yeah, this is the equation that I wrote. Well, it precisely is the landscape, the r squared 8 cosine 2 theta, and then outside the circle of the r equal 2. Okay, supposedly the AI understand the context. I assume he understands it, and he gives some pointers, and this is really important for your quiz as well and for your review. He gives some exact order what you need to do. Okay, to find the area, blah blah blah, we first need to find the points of intersection, which is true. We need to find the intersection points. That is true. Okay, find the points of intersection, which we set this equal to that, and we get the theta, right? Which theta we are going to evaluate. Okay, so that's the first one. Maybe let me zoom a little bit. Can I zoom? So find the intersection. The second, then integrate the area. So it gives the formulation for the polar, which is true. How? And then integration r squared from theta 1 to theta 2, right? Okay, that's no problem. And then subtract the areas, because we are also expecting there will be some subtractions, because we have something, some area that are going to lose, right? It's the subtracted area. Okay, the total area we are looking for is the landscape minus the circle from the point of intersection. Okay, seems to be true. It seems to be true, and I think generally it's correct. Generally it's correct. The procedure is correct. But the interesting thing is, let's start with the finding intersections. Okay, he goes with the Python code. Okay, and then solve finding solutions, blah blah blah. He deals with this, define the variable. He make this theta as variable, okay, and then result is coming out 0.5, 2.6. So he get this two value 0.524 and 2.618. He argued that this will be the radius for the theta 1 and theta 2, which I think I haven't checked, and maybe if you can check, you can check as well. I think maybe there will be some problems here, because you see that if we think in Cartesian and suddenly we move to polar, sometimes we are not familiar and we need to adjust, right? I think that is happening with this. Okay? I think he doesn't prepare very well for the computation. Okay, he got that, and then to find blah blah blah, then we need to subtract. Okay, the area inside is this for the lemniscate, and then the area for the circular sector of the circle. Then he need to subtract the whole area, and then he get this. Okay, let's calculate this area. And I think this also can be some trouble too if you are not aware. Okay, let's calculate this area. Okay, analyze. Okay, he imported from the library, blah blah blah. Taking the integrations and define the solution theta 1 and theta 2. Okay, and then taking the A1, A2 for the lemniscate and the circle. Total area, the first one minus the second one. It seems okay, but I think there is a problem with the angle. And then he got this is negative 5.5. So it's still, he's still in command. I mean, he's still thinking. Okay, it appears there was a misunderstanding, blah, 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 because it's negative. Because the area, he got the negative area. Okay, and then he tries to correct himself. Okay, let me correct this by computing appropriately the total area. Okay, and I don't think he makes some adjustment. Oh wait, okay, he make a good adjustment here because he basically get the same result, negative 5.5. He doesn't give up yet. Okay, so there is a mistake. And then give the unexpected result, the calculation was not corrected as intended. Okay, and then he tried to correct himself. Okay, since the direct calculation led to confusion, I will reevaluate. Okay, he tries to reevaluate. Okay, and then I forgot how he made this correction. Oh, he made this correction with this, I think. He made this correction with this, which I think made another mistake. So he tried to multiply with 4 because he was thinking that the theta 2 and theta 1 is by the symmetry. So he multiplied by 4, which I think since he had mistake at the beginning, he tried to correct that mistake by take another layer, and then it make another mistake. Okay? It make another mistake. And he got the result is negative 7. Now it's increasing. Okay, calculation have consistently resulted in an incorrect interpretation. Blah blah blah. given the goal is to find the confined with specific region defined by polar curve, a negative result is conceptually incorrect. Okay, he got the concept. Okay, it's incorrect. Okay, the correct approach involves more carefully integrating the area, blah blah blah, and then to clarify the intent. Okay, so to clarify the intent was to calculate the positive area contained, blah blah blah, and given the complexities, he's like writing really long, saying that he's actually give up. Complexity and repeated oversight, the precise resolution of this requires re-evaluation. So he wants re-evaluation, which means that he needs some direction. Okay, okay, and then I came to help. Let me help you out. So let me help you out. So I help him. I help him. I consider him as my student. I help him. Okay. So you can so you can use symmetry. So I give a pointer that you can use symmetry for the polar curve. So I give a clue. You can multiply 4 times the area from theta 0 to theta pi over 6, which is the integration. And politely he's answering, thank you for pointing out the use of symmetry, the problem, which indeed simplifies the calculation. Given the symmetry of the curve, r squared equal 8 cosine 2 theta and this circle r equal 2, and evaluation with this, and then he now give correct solution. Now he gives correct solution. So I think the first mistake he made is the angle. I think the very first mistake is the angle. I think the first angle, the 0.5 radian, I think that is correct. The second radian, the theta, which I think is not correct. And then he tried to correct that. And then he doesn't change the angle. So that will be like layering the mistakes. Okay, so that's the problem. Okay, now it's correct. And then he gives the final result in the Python. Yeah, if you calculate, it is correct. This is actually the solution. And if we compute the using calculator, this is the answer, 2.73941. Okay, so actually, like this is a problem because of context. Like if you deal with this kind of problem, the first thing is to see what is actually we are going to evaluate. Like here, what should we do? Is basically we want to take this, right? So basically, we want to make sure, like, if, and it is already given the angle here, which is true. This is the intersection, right? So the idea, if we want to imagine how the polar works, we need to think like polar. Okay? So if you want to, for example, the landscape here, right? Okay, so we are going to see that if we take that from 0, let's say 0 to pi over 2, let's say this one here. This is landscape 0 to pi over 2, right? Start from here and then goes up and coming down, right? Okay, that's it. So the same thing, if we end the angle up until pi over 6. For example, if we take this until pi over 6, we are going to get, okay, I think we get here. Okay, let's see this. So here, supposed to be the landscape. And then this is the, should be, let me change the color to match the circle. Very bad circle. So what is actually we're looking at? We want this area, right? So it means that if this is the polar axis, it means that if we take this as pi over 6, it means that this shape here is our, let me scale from 0 to pi over 6, okay? This one here, okay? Okay? This one, okay? This is the area 1, okay? Now if you see the circle from, let's say here, the new circle. From 0 to pi over 6, this is the circle. So the circle is going to be inside here. So the green one is A1 and the blue one is A2. So which means that this area will be A1 minus A2. Okay? And then since they are symmetry, 1, 2, 3, 4, multiplied by 4. Okay? So this is the total area. Okay? The important thing is not how to calculate. The important thing is to see the area correctly. To see the area correctly. If you're not seeing this, then at the very beginning it will be wrong. The whole your computation will be wrong because you have the wrong assumption, and that's how ChatGPT got wrong. He got wrong assumption at the beginning. The angle is wrong. Okay, got it? Okay. Any questions? I think the first one actually quite needs some thinking, but for this second, I think the third one, you can go directly to compute, right? So basically, you have the point, which is the x1, y1, which means that you are going to put t equal 1 to get the x and y from here. And then you get all the derivatives from here. So you have x, and you can derive, and y you have derived with respect to t for all of them. And carefully when you derive, and then finally you get the dy dx, and then using this point, using the slope, and you get the equation. Maybe I will start with the second question. Okay. If we have time, I will write also here, the third one. But hopefully you can try just to write out the formula and derive this, just to warm up yourself, to get to know how to derive this, like reviewing your calculus 1. About the number 2.
Number 2, you have the x equal cosine t plus t sine t, and y have the sine t minus t cosine t. So whenever you see the trigonometric and you can see some relations, the expected outcome or the expected process is maybe we need to solve or simplify these sine and cosine, which we can see from the equations. Okay, let me. Okay, let me write here. Remember, in parametric, there is only one formulation for the length, which is this is going to be from 0 to pi, and this is square root of, let me write the formula first, okay, just to let you know, dx dt squared plus dy dt squared. Okay. So we can start taking the derivative for each one of them. So let me write x prime equal, this will be negative sign. And then we are going to have a product rule. So this will be plus t. But to avoid mistake, I will make a parenthesis. So t cosine t and plus sine t. So this will be t cosine t. Okay. So dx dt will be t cosine t. And the same thing, taking y prime, cosine t, and then minus, I will take the product rule, minus t sine t and plus t cosine t, sorry. So you will see that this will be t sine t for dy dt. And it is actually a pretty good formulations, right? So you have integrations and then square root of this squared and that squared, and then taking dt. Oh, I forgot dt. I forgot to write dt. Okay. So you will get that this will be resulting in t squared. Take the square root and we can remove the square root, right? So we are going to have integrations from 0 to pi t. So this will be t squared over 2 from 0 to pi, or this will be pi squared over 2. Kayaknya.
Jadi cuma ikut sama about-nya itu ya.
Yes. Iya.
Ini nggak apa-apa kan, langsung gini aja. Oke, nggak apa-apa. Kok menjijikan gitu ya, Sir?
Hah?
Kok jadi menjijikan gitu ya, semuanya langsung masukin gitu ya?
Tapi kan selama bisa dipertanggungjawabkan ya mas. Yes.
Ini kenapa kok eksperimen jadi gini?
Itu kan power rule.
Produk rule.
Oh, yang T-sign-nya.
Iya.
Oh, good point. Product rule.
Okay, so let's continue. Okay, so continue. Let's try number 3 and then number 1. Okay. Or do you want to try by yourself? Or have you tried before?
And that's why. You can try beforehand. This is also reviewing your calculus one.
Hmm?
Coba kamu tambahin. Bisa keluar nggak? Itu ada.
Oh gini loh, ini loh alurnya. Saya bisa bikin kan? Ya udah.
Oh ini satu ya?
Iya. Dari situ aja.
Okay. Or anyone would like to try the number 3?
Okay. Your turn.
Which is strange, so I want to know. No,
Okay. Okay. It's okay. Maybe you can write here. It's okay. It's okay. It's okay. I will help you. Yeah, I need to make sure that yeah. Actually, you don't necessarily need to draw, but you can imagine that this will somehow have some that y equals 0. You can find that 0 is intersect that big point partial. You're going to find where the t minus t squared is 0. And that could be the basically that is take a shortcut. Take this as is 0, y 0. The y. You really have to t, right? You have to t. Actually, It could be works if you see the graph. Yeah. So that's why I think the question needs to have a little bit more information so it can be solved clearly. I think that is some points on
Okay, but the derivative I think correct. The derivative part.
The XDP. I just did this.
Okay, so okay. Okay, so first since t is 1 based on the information, then we can take the point. Let's say we have the point here. When t is 1, then x is e and also 1, right? Okay, that is the xy. And then writing down the derivative. So let me write, this is dy over dt. This is dx over dt. And this will be 1 minus. Okay, let me walk
you through some review in calculus very quickly. Okay. Every time you see this, it seems like complicated, but if you see from major perspectives and then see the inside of the function. So let's say the function starts from like a big function. The big function is the ln here, ln, right? ln is derived, it's 1 over whatever inside. Okay. So it's derived, so it will have 1 over t squared multiplied with whatever inside we derive. Okay.
So this will be one over t squared, and then we multiply with 2t. And then dx dt. The whole function is e. The big function is e. So we could just take the e. E is just the same, but we multiply with the chain rule, which is this. And then we put t equal 1. This will be negative 2. This will be what? Half e. So negative 4e. Oh, wait. Negative 4 over e. Can you help me? Is this okay, right? Huh? Why not okay? Right? Okay. Okay, and then at the end we could just take the line equation. I think we can just write this as okay, and then we just get the result, right? What? That's why I feel this is wrong. I feel this is wrong, but I'm not sure which one is wrong. Oh yeah. Oh right, yeah. Okay.
If you do the same mistake as me, you still get still like 80%. This is the error in computation. Yeah, why I put maybe this I didn't see that.
Okay, so if we see the first one, since
Okay, the first one is the correct idea is you can imagine how it looks like. So we have two parametric x and y, and also we have the x-axis. We have the x-axis. So you can imagine, for example, you can take y, and you need to make sure that y is going to intersect the x-axis. Okay. How to make sure we get the x-axis is by taking the y equals 0. Right? That is the x-axis. So that will be our boundary. So the intersection, it could be
When this is going to be equal to 0. So the boundary between this and x-axis, this could be written as t minus t squared equals 0. So we are going to have, oh wait, t is 0 and t is 1, right?
X-axis is 3 plus e.
yeah.
Yeah, I think, let me add here. Okay. I want to make a graph based on this. Another way is taking this 0 and 1, okay, taking the 0 and 1, and then checking the x and y. Okay. Or if we want, like, can we combine this x and y and make a xy Cartesian? I don't think it is that simple. Okay. But if you try to draw, so I believe this question that's number 1 because I took it from somewhere else. It need to give you some other information to make sure that what we did is clear. So
By, first of all, to solve this, assumptions that this and all of this will have the same intersection and boundary. So when we have this boundary with this, it means that there is only two parameters that is going to make this y0, which is 0 and 1, and that is actually
is going to be the area of the boundary. So this will be 0, 1. Okay, 0, 1 of the so this will be the t minus t squared, and this will be the x prime will be the e to the t and dt. Okay, so actually this could be our solution, but I think we need to check with graph. Okay, so I will let you know if I have checked in with the graph. Okay. So if we compute this, at the end, this will result in 3 minus e. Okay. Okay. I think I have other questions. Okay, I have this other one here. Okay, maybe for the last half hour, let's try this one. I think for the first one,
It's quite clear that this rows inside the lemma, right? So all this will be subtracted by the big one, right? So you can just use 0 to 2 pi and then minus the other one.
okay. For the second one, the first thing you can do is finding the
Intersection, at least this point here, you need to know the angle.
okay. Let me do the first one, just making the whole formulations. So this could be done by taking the area, and let's just taking from 0 to 2 pi, and taking all the informations. The big cardioid, 3 plus 2 cosine theta squared, and then minus. And maybe let me write the half outside here. Okay. So this will be sine 2 theta squared.
So I think I just remember. I think for your exam, still you need to do some steps for calculation until at least some very nearby the final step. Then you can complete your calculation. Yeah, for the very beginning, for a few parts of the beginning, you can do the integration.
Okay.
But can you do this one? I mean, this integration? Okay, right? I'll still have some difficulty. Yes? I think the best way to remember is this. The polar should have this. Right? You can go back from this point. I would like to, if you still have struggling here, this one, integrating this. Okay. And I think in most of the problems, you might encounter trigonometric with a square, right? To solve that, use the double angle formula. Use double angle. And basically that, most of the area in polar, and for your quiz, there will be at least one this kind of question. Okay. I give to you. I give to you. I will draw for you. Okay.
Okay, maybe let me go for the second one, just to set some idea, okay? Like ChatGPT mentioned. So first, finding the point of intersections. So we would like to know the intersection point here, right? This one. So we set the 1 plus cosine theta equal 3 cosine theta, which result in cosine theta equal to half, which indicating that at least in the first quadrant, theta will be pi over 3. This is this angle here, right? Okay, let me just write pi over 3 over there. Okay, now I think to help you with the how to imagine the area itself, we can just define the two shapes. Okay. First is the cardioid. So let me draw here. The cardioid is maybe this way. Very bad. Okay, let's say this is the cardioid here. And let's say this is our pi over 3, maybe here.
If you could see from this shaded area here, you see that this is actually, if we are thinking this part of the area, you could think the cardioid is going to be shaded from this and then over there. Let's just make that happen. So we are going to take this pi over 3 as our first step to shade the area from here to here, which means that
This will be our first area. Okay, that. Okay. So this I will write that the area is going to be from pi over 3 up until pi. Okay.
Because it's up to here, right? This is pi, right? Okay.
Now the circle on the cosines that side. Let's say this is the area. This is pi over 3. So we have those. Okay.
We have this, right? Remember, this is starting from here, and we swept through here. Well, we have this intersection, and our area is from this, right? Up until here. So this will be our area for the circle. And circle is going to be this, here, right? So we need to subtract this. I think similar to the Doraemon pocket. And then we need to subtract this with this. Okay.
So let me add here that this is supposed to be with the green one. Supposed to be this. Okay. So what we have actually, we are going to have pi over 3 pi, and then half 1 plus, let me write one by one, okay, cosine theta squared. This is for the cardioid, minus this one. Oh, I forgot to write. This cosine is from pi over 3. It has different angle, right? This is until it's not pi, it's pi over 2. And you can confirm pi over 2 from
our cosine angle. It goes 0 when it's pi over 2, which is true, right? So this circle here is pi over 2, not pi. So this is the difficulty with the polar. You need to understand each one of them. Each curve, they have different context with each other. Okay? So we kind of really take the integrations and then take the subtraction directly. It doesn't work like this. Sometimes it has different intervals.
So let's write down here. This will be from pi over 3 until pi over 2 for the circle, which is the half, and then 3 cosine theta squared. Okay.
Arriving at this is really big a portion. So if you have this correctly, like you are maybe 70% in 70%. Truly true. This is really, really important. Really important. And the rest, the integration part, I hope you can do it. Yeah, I hope you can do it. If there is some mistake, still you have like a big percentage. So the important one is how we can see this. Okay. So we need to separate this, okay, and then always think in polar if we are in polar. So how we take the movement of polar, we start from this. Always take it from here. Take theta equals 0 and then we move. And to confirm, always check and make sure that we have arrived at the correct angle. Like for example, I want to make sure that what is the angle here, and I say, oh, it's pi over 2 because that is when this is going to be 0. Okay. I hope that is very clear enough. Yeah, you should be careful. You should be careful.
How does that happen? If I put our circle inside of the integral with cardio, I mean, like, does it really make difference?
Depends. Sometimes.
I mean, like, I see that my radius is from my cardio to my circle on between angles P over P, T, P. I mean pi. Why do I need to separate them? This function.
Sometimes because the trigonometric has a positive and negative value. There will be some mistakes. It might happen if we are not correctly using correct
Yes, but
yeah, sometimes that is why we testing yeah, he got the negative because it is his way of thinking. Okay, it's subtract. But actually, we need to see the context. Sometimes maybe if we can use symmetry, then try to see the symmetry because sometimes there will be some mistake happening in between. So it's good to make sure that we are getting the correct result. Okay, any other question? Any questions?
If not, I think this will be the last. And yeah, basically that is my exercise. And hopefully you can also try find other exercise as well. Okay. So wait. Yes.
Technically, if we take our until the same like range, it won't have an effect.
You can try.
But it's like not sure. It's better not to.
Sometimes it can have effect, sometimes not. Maybe for this one, maybe no effect, but I don't know if in another case will have effect.
So to be more careful.
Yeah. That is just my awareness. Because pi maybe not really effect for the cosine. Yeah. Okay. Yeah, that's why we need to make sure, right?
I use the endpoint of pi over 2 and try another endpoint of pi and show out.
Okay. Good. So I think very careful on the endpoints. Okay. Okay, if there is no question, maybe let me get through. Okay, the attendance for today.